When a single language model attempts a complex, multi-step workflow, it eventually breaks. As the model loops through extensive reasoning tasks, it has to store every prompt, tool call, and intermediate output. Its context window fills up. When that memory approaches saturation, the model loses track of early instructions and begins hallucinating or degrading its outputs. If you chain these logic blocks together in a monolith, a single hallucination at step 2 corrupts steps 3, 4, and 5. Furthermore, forcing one model to execute every subtask prevents it from maintaining specialized domain expertise. It has to fetch raw data, run quantitative calculations, and write a polished summary, all while trying to maintain distinct analytical frameworks within a single overarching prompt. Overcoming these bottlenecks requires an architectural division of labor, not just expanding the context window. CrewAI is a framework designed to decompose heavy workloads into discrete role-bounded tasks. Instead of a tangled prompt chain, the framework relies on a tripartite architecture: agents, tasks, and crews. To test this architecture, we will engineer an automated equity analysis pipeline targeting the National Stock Exchange of India. The objective of this pipeline is to pull raw market data, run risk assessments, and output a highly structured classroom equity watchlist report driven entirely by deterministic JSON logs. Transitioning from linear chains to multi-agent crews shifts the developer's role to systems architecture. The first primitive is the agent. To initialize it, assign a language model, goal, and a precise role, like Senior NSE Analyst. Then inject a backstory. A veteran analyst evaluates data differently than a junior. This programmable persona shapes the model's entire reasoning style. While backstories successfully steer the domain framing and the level of caution the model applies, they do not guarantee factual correctness. To secure accurate data, we inject custom tools, like an NSE data scraper, giving the agent the external execution capabilities it needs to verify its analysis. An agent is a tightly constrained computational persona equipped with specific access rights. The second primitive is the task, a discrete unit of work explicitly assigned to an agent. The most critical constraint is the expected output. By applying pydantic schemas, we force the output into a strict JSON structure, containing specific keys like ticker, EPS, and revenue. Defining this output schema per task is mandatory for multi-agent reliability. Without it, agents return conversational text instead of actionable data payloads. Schema enforcement prevents version-specific ambiguity across different language models and eliminates hallucinated data formats. Practically, we use this to instruct our research agent to pull Q4 2025 financial metrics, specifically for Infosys, ensuring exact numbers populate the designated fields. Tasks enforce the architectural boundaries of the system by strictly guaranteeing that downstream agents receive parsable, structured data. Since these agents are autonomous and isolated, they require a mechanism to share complex findings without breaking their boundaries. This is accomplished through state injection using the context array. The first task passes its synthesized Q4 metrics forward. This payload triggers a secondary task, instructing a new Quant Strategist agent to compute price-to-earnings ratios based on that specific dataset. The framework scales this logic to aggregate data across multiple IT sector targets, pulling in companies like Tata Consultancy Services. Context injection prevents context window saturation. By passing only the synthesized, structured outputs, rather than the entire raw history of the prompt, the memory load remains light. State injection turns isolated agents into a directed, continuous reasoning pipeline. The final orchestration wrapper that binds the defined agents and tasks together is the crew primitive. When assembling a crew, you select a process mode. The sequential mode is a strict, linear sequence operating deterministically from data fetch to final report. Alternatively, the hierarchical mode generates a Manager LLM, dynamically routing subtasks to specialized agents based on the overall goal. These modes carry engineering trade-offs. Sequential is faster, cheaper, and optimal for clear ETL pipelines. Hierarchical handles ambiguous objectives, but at the cost of strict determinism and compute efficiency. Scaling analysis to massive multi-sector conglomerates requires complex workflows where dynamic risk assessment is necessary. Selecting the process mode is your most critical architectural decision. It determines whether the system operates as a rigid script or an autonomous management layer. To initiate the orchestration loop, we run the kickoff method. Tracing the execution logs chronologically allows us to see exactly where individual tool executions start and complete. Based on the parameters we established, the system autonomously triggers the NSE Fundamentals Lookup tool to gather the raw market data. Deep within the terminal trace, we can verify that context passing succeeded and that the Pydantic schemas successfully validated the data payloads moving between agents. Observing a clean terminal trace proves that the architectural boundaries and state machines hold together under live execution. With the execution loop complete, the system synthesizes the deliverable, a structured classroom equity watchlist report. The crew drew a definitive analytical conclusion, selecting ICICI Bank based on peak revenue growth paired with positive technical signals. Tools fetched the raw data, Pydantic schemas enforced the structure, and Backstories drove the analytical perspective. Multi-agent orchestration is a distinct engineering discipline from chaining basic API calls. CrewAI gives developers the primitives needed to architect systems of discrete, role-bounded, self-validating stope machines capable of deterministic reasoning.